tool than it really has to do with performing the procedure correctly. I think you can use all the OEM stuff, and it may not be calibrated correctly. Even if you try and do the procedure, you move the target incorrectly, it's just not going to calibrate. So I've been pretty outspoken about using aftermarket tools, but I've used some of the aftermarket tools, and I have kind of found some interesting things about them. So I want to talk about how they work and how they operate, and then you guys can obviously make your own decision on how you feel about the aftermarket tools. So I wanted to do a little demonstration, and I wanted to, if I can get 2 volunteers that have a camera phone, a pretty good camera phone that'll take a nice picture. Anybody want to volunteer? Awesome. And you don't have to do much. All you got to do is sit in a seat. If I can get one more volunteer, I appreciate it. So what we're going to talk about, we're going to use, I believe the vehicle we're using is a 16 Honda Accord. It's either 16 or 18, I apologize if I forget. But this particular Honda Accord uses a 3-target system. And those 3 targets you're going to see up here, that's what the factory tool looks like. And you're going to set those targets up, and what you're going to do is take a bunch of vehicle measurements, and you're going to set those targets up away from the vehicle on the vehicle center line. So, what's your name, sir? Rob? Bob? So Bob is going to be our test guy. He is going to be the vehicle center line, so he's going to be the imaging camera for this calibration. And as you can see, these targets are pretty large and pretty spread out. So with a lot of the aftermarket tools, they knew that they couldn't make a tool that was that large and be able to fit it in all the shops. So the procedure is a little bit different, where Honda will tell you to put these targets this far out and separate them this far apart. What we're going to do is we're actually going to make these targets a little bit smaller and bring them closer to the vehicle. So now what this camera sees is actually a 2D image. When it looks at this 2D image, it can't tell how far away from it is from the vehicle. So in theory, that procedure should work, and it's kind of irrelevant if you bring a smaller target closer. So really what you could do is you could probably put a tiny little picture right in front of the camera and get it to take, as long as you have it in the correct position. And I can tell you that correct position is very important. If we set these targets up and they're off by an inch, chances are it's going to fail. It's, in my opinion, kind of harder to get it correct than it is to get it incorrect. But again, precision is important in these calibrations. So looking at these targets, there's a couple different ways you can do it. The scan tool will allow you to do all 3 targets at once, but they also recommend that you do them one by one. And so when you do the procedure one by one, you're going to take a shot of the target in the middle, you're going to then take a shot of the target on the right and then the left, or vice versa. So when you do that, what that allows the aftermarket tools to do is use one target on a stand, and they make that target a little bit smaller and they move it closer to the vehicle. So when we do that, we're looking at the targets, and I just set these up. These are not to spec, these are not to scale, these are not any measurements. I'm just using this as a reference to kind of show you guys how this works. And this would be the vehicle that we're calibrating. So we're going to set it out in front, and you, sir, are going to be my camera. You are the Honda Civic camera for this event. And if we can see, we should have the center line sitting right about on the center of your head, just about. And so you will be the center line of the vehicle, and we can take this target here, and if you could hold this target out in front of you and kind of set it up to a point where it pretty much lines up with these 3 targets. So you have to kind of hold it out in front of you. And so do you see how that image can essentially look? We could duplicate that, right? Fairly close. So what we'll do, and actually I guess I'll do this for you with my camera phone, is if you don't mind, I'm going to get right in your face here, and I want to take a photo of what you see. So we are going to snap a picture. And it's pretty close. It's not perfect, but we're pretty close. And obviously this isn't to scale, but do you see how we can do that with a smaller target by moving it closer to the vehicle? And if you're of the same opinion as me, this should take, and it should be possible for you to do that correctly and to get the calibration to take correctly. Does everybody kind of agree with that? So that is the procedure that they're following, and at first I think they were having a lot of issues, and sometimes they're getting them to calibrate, and sometimes they're not getting them to calibrate. And when I started looking at this, I started looking at it and it didn't make sense to me. And the reason it didn't make sense to me is because when you look at these cameras and you draw a center line on the vehicle, that center line is where we're placing our target, right? So our target in the aftermarket scan tools, it will tell you place the target on the vehicle center line for your center measurement, and then it'll tell you to move it X amount of millimeters to the left for one measurement, and then X amount of millimeters to the right to take your other measurement. So there's 3 measurements you take. And both of those measurements to the left and to the right are equal numbers, at least as far as I've seen. So if they're equal numbers and they're not working correctly, or if sometimes they fail, we want to figure out why. So what I started looking at is we draw our vehicle center line, as you can see up here. And our vehicle center line is where we're going to place that target on for our middle target, and then we're going to base our left and our right target based off of that center line outwards. Well, when you look a little closer at this camera, what do you see?
It's offset.
Exactly. So if the camera's offset, but we're still doing our measurements closer to the vehicle, then essentially we're probably not calibrating these correctly. Would you agree? So another way to explain this, or another way to show this, is if I printed these 3 targets here, and I take these 3 and they're static, but if I put them on a wall and I look at these targets from an angle, that is a dramatic version of what we're doing here. If our camera's offset, we're actually looking at these targets from an angle. So now if you hold that target back up about where it's comfortable, now if you take a picture here, and let's say you're the camera where it's offset, I'll do it on my phone so that they're both the same. And even if we get really, really close, I can't even get those targets in the frame, right? So now, with those images, that's very dramatic, right? Because again, this camera is only maybe an inch or two, a few inches offset. It's not very far, but it's still not completely correct. So if we look at it, and we take these shapes, right? So this is what a 2D image will see if we take this target and we look at it offset. So you can see here that I copied and pasted these 3 red circles after I drew them over the image, and then I copied and pasted them up above where they are. And I also drew the blue line and the green line to represent the distances between the targets, and then I copied and pasted those to help visualize the difference in what you're looking at if the camera is offset. So now we can kind of make the decision on whether or not we think that these things are calibrating correctly. Sometimes they do calibrate correctly and then they go down the road and maybe not set lights. But in my opinion, I really don't believe that is 100% correct. I am also of the belief that these things are dynamically calibrating on the road. And I feel like when we do a static calibration like this, it doesn't necessarily mean that it's not going to dynamically calibrate and be able to adjust for any differences in the static calibration versus where it should have been. So I thought this was kind of interesting, and I wanted to share it because I was completely of the belief that an aftermarket tool should be able to perform these calibrations if done correctly, just as well as an OEM tool. But I have also found out that I don't believe that they're doing it correctly. So that is something that I would suggest keeping in mind when you're looking at aftermarket tools, although there aren't a lot of them available that will allow you to do these static calibrations out on the market now. And I'll be curious to see if they change the way that they operate these. Would we have to change the size of the targets and the shape of the targets? I don't know. I don't think that it's that much of a difference as close as that camera is, but I definitely think we should be changing the measurements of where we're moving these targets to do the calibrations differently. So, I appreciate your guys' help.
On the subject of after